So in the last lecture, we discussed the contents of the course, and now we are going to discuss course learning outcomes. So you see, after successful completion of this course, you will be able to first analyze 2D and 3D force system and calculate moment in a 2D and 3D structure. So this is the first thing which you will be able to do after completing this course successfully, that any force which is given in one plane or it is given in a space, you can easily calculate its components, its projections. You can convert these forces into vector form. uh, these forces about different points. You can take the moment of these forces about different lines, about different axes. So you will be very comfortable, inshallah, after completing this course as far as the analysis of forces are concerned. So this will be the first thing which you will be able to do after a successful completion of this course. And after that, after completing this course successfully, you will be also able to analyze beams and frame structures. What it means when a beam is given to you with certain loads, you will be able to calculate what are their internal forces, yeah, and what are their magnitudes. Okay, same thing you can do with the frame structure also, that you can calculate, especially at the supports, what are the reactions, or at the joints, what are the forces that you can determine after completing this course successfully. And after completing this course successfully, also you will be able to analyze truss structures. This means those structures which have the long, thin members. Okay, what is the magnitude of forces in these members, and also what are the support reactions, or what is the force at the at the junction of the two members. So all that you can do easily after completing this course successfully. And these are the two things which are directly related to mathematics, but you require in many places in engineering also. Yes, yes, yes,
Uh,
Muhammad.
Doctor, I have a question. What's the
Yeah.
difference between beams and truss?
Okay, we will discuss this in detail when we'll come to the to these topics. But you see, beams, that is true, beams and truss both are used for supporting the roof. Okay, like if in most of the masjid, if you go, you will see that the roof is supported by a horizontal members which are called beams. So the load on the roof or load on the floor transfers to the beams, and beams are supported over the columns. It transfers from the beams to the columns, and then from columns to the foundation, the load goes, and then from foundation, the load goes to the ground. So this is the structure of the load transfer. And let me show you uh, some pictures so that if I am able to share. Unfortunately, this time this is not share application is not working. Mm. Okay, even here I can tell you see, beams are horizontal members like this, having the generally rectangular cross section. Mm. And if suppose this is a roof, Then just under this we provide the beams. So what happens, whatever load is acting on the roof, that load will transfer to these beams. Okay, that is at the corner, at the ends of the roof, and then they are supported over the columns like this. So the load from the roof to go to the beam, and from beam it goes to the columns, and then columns are supported over the foundation, and then to the foundation, and under the foundation there is a soil or ground. It will transfer finally to the ground. So the ground must be strong enough to take the load. So this is called beams. In case of truss, truss is of this type of shape, which is generally used for the supporting the roofs. So you can provide even the trusses here. For example, here you can provide the truss, okay, like this. It has the members. So the
So
trusses are generally used in mustaudas where the open space is very large. Eh, So you can have you can support this roof over the truss. eh. So but in trusses you don't have the continuous like concrete member. Generally it is made up of steel. So it has the thin steel rods like thing which is supporting the roof. If you go to any mall and you go to the top floor where there is a playing area for children, you will see the roof. It is supported by some very thin rod type members. They are basically the trusses. Okay, so when your open space is very large, then we go for the trusses because trusses are very light in weight and also very cheaper compared to beams. Because and when you have the small open space, then you have the continuous roof, and these roofs are supported by the beams. Like as I said, in most of the mosques or in your houses also, the your roof are supported the by the beams. Is it okay?
yes, and both have the same capability to support the roof, right?
Yeah,
Or
both have the same capability, but beams are much expensive compared to
yes.
the trusses. Yeah. So generally, for very large open spaces, we use the trusses, not the beams. Like in the workshops or in the, as I said, in the malls where there is a big open space and you have to support the roof, then there you use the trusses. And where the open space is small, then the roof you can support by the help of beams. Okay, let me come back. Okay, so and then after completing this course successfully, inshallah, you will be able to calculate the centroid of regular and composite cross sections. If you have regular shapes like a rectangular shape, you have, or you have a triangular shapes, okay, or you have the circular shapes. So these are the regular shapes, and the composite shapes may be like, so how to we will teach you how to find out the centroid of these type of shapes, and also to how to find out the centroids of the regular shapes. Okay, so after completing this course successfully, inshallah, for regular shape as well as for the composite shapes, you will be able to calculate the centroid easily. And also after completing this course, you will be able to calculate the area moment of inertia of various types of engineering section, regular as well as the composite. Like for the same sections, after completing this course, you will be able to find out the moment of inertia about this axis, or about the centroidal axis, or about the axis passing through the top, or in case of this, about this axis, about this axis, or about the axis passing from this point. So about different axes, x-axis, y-axis, z-axis, or the axis passing from this point, axis passing from that point, you can calculate, if inshallah, if you learn this course properly. So, and this, as I said before, that the area moment of inertia and centroid, they are the topics of mathematics, but we are teaching them over here because of their large application in engineering. eh. So, especially in civil and mechanical engineering. So, those who are from civil and mechanical engineering, they will be using the knowledge of finding out the centroid and finding out the moment of inertia throughout their engineering studies. And finally, after completing this course successfully, you will be able to analyze and solve friction related equilibrium problems very well. And I had given you example in the last lecture that if you have a if you have a inclined plane like this, an inclined slope, and in this you want to park your car, sorry, he could not make it properly. Okay, so these are the two separate wheels, one wheel and this is another wheel. So as you know, due to the component of gravity, this car will try to slide down. But because of this friction force, which is always opposite to the direction of possible motion, that will try to keep it on the inclined plane. If this force was not here, it was not possible to park your car on the inclined surface. It would have gone down. So in such problems, your friction force, it is the major force of equilibrium, and that is the reason why we are studying this friction in statics. And inshallah, after successfully completing this course, you will be able to solve such problems comfortably. So these are the things which we are aiming to achieve after completing this course successfully. First, after completing this course successfully, you will be able to analyze forces in 2D as well as in 3D, and you will be also you'll be able to analyze beams, frames, and trusses, and you will be able to find out the centroid of different type of engineering sections. You'll be able to find out the moment of inertias about different axes of different engineering sections, and also you will be able to solve the friction related equilibrium problems. We will assess your learning through 3 exams and some other homeworks and quizzes. So we will examine your learning, or we will assess your learning with the help of 2 midterm exams that will cover about 50% of the evaluation. And then we will also have, you will also have tutorial classes, and also you will have a model demonstration class. So that will constitute 10%. In the model demonstrations class, you will go there and you will see different models of statics, and you will perform some experiments over there, and then you will write a small reports over those experiments, and based on how you perform in the model demonstration lab and how you perform the tutorial classes, eh, we will assess you mm, out of 10. So 10% weightage of assessment will be given to these two. And then at the end of the semester, we will have the final exam, which will constitute 40% of the total assessment. Okay, this way we will have 100%, 50% two midterm exams, 10% for tutorial and model demonstration, and 40% for final exam. So the total becomes 100. So this total becomes 100. Now, if you have learned this course almost perfectly, then you will be entitled to achieve A plus. So A plus we allowed for those students who are showing in their assessment 95% or more marks. And if you are done the course excellently but not up to perfection, then you will get A grade. And if it is very good, then you will be get a B plus, and it is uh, fairly good, then you will get B. It is only good, then it will be C plus. Uh, fair, then it will be
A
C.
plus,
Pardon.
A plus,
Yeah, this grade A plus. Yeah, you should target A plus perfection. Okay. Always our aim should be high. Hmm. Okay.
inshallah.
So inshallah. And so uh, actually, students think that teachers are very picky and they want to give not good grades. This is not true. Actually, what you achieve, that is also indicating how I performed. Eh, my assessment is your performance. Eh, if I did not perform well, eh, then if you do not get good grade, that means I did not perform well. Hmm. Because if I had discharged my duties properly, you would have got you have done better in the exams. Okay, so performance of students is also indicator of the performance of teacher. Okay, but of course we have to maintain the justice. We have to not means like uh, a student who has not learned anything, and if I say him is very good, this is khayanat. eh. Why it is khayanat? Because based on your performance, you will be given the position in the engineering job, and if your grades indicate that you are A plus, and when you go over there, they will be expecting from you that you will do A plus performance. And if you performs there like a D grade, then of course they will say who was the teacher who gave you A plus and taught you nothing. So we have to do the justice. Okay, so that's why we give uh, how much you have learned, based on how much you have learned. But of course, we feel more sorry when you perform bad because this is a clear indication that teacher did not perform well. Okay, so our performance is your performance. Okay, so this is the distribution of the grades. And as I have said you before, to do good in this course, especially, uh, the strategy which you should follow the day when I take the class, when you go to your home, eh, at least go through those slides which I have covered in the class. And you will see my speed is very slow. Hardly 5 6 slides I covered in one lecture. Okay, so those 5 6 slides you can even brush up in 10 minutes. But if you give on the very same day this 10 minutes, that will make a very, very big difference in your final performance. Okay, so the strategy will be go from here, go through those slides which I have covered in the class. If I have covered some problems in those slides, solve those problems by your own hand eh, number of times unless you feel that okay, anything of that type I can do. And after this, you go to the book. In the book, you will find the articles which I cover in the class in 1 hour. You will find just in one paragraph it is mentioned in the book. So covering the one paragraph or half a page, it's not a big deal. You can read it and you can make your knowledge perfect. Because keep in mind, lectures are not the substitute of book, and books are not substitute of lectures. So if you want to have your knowledge perfect, that's why I say perfect. Only perfection, those who achieve perfection, they deserve for A plus. So for getting the perfection, after reading the slides which I have discussed, you go to the book and read there. I'm telling you, you will enjoy. Yeah. And even the language will not bother you. Yeah. This half page or one paragraph which you are going to read in the book. Okay. And this way you will make your knowledge uh, perfect. And after that, depending on your convenience, you practice as much as problems from the textbook, from the solved problems, from the problems which we have given in the previous exams, okay, or from muzakkarat, any source you can use to practice. So more practice, more and more you will be perfect, okay. But this should be strategy. And I'm coming to Muhammad. But my experience says that majority of these students, they do opposite. First thing, they don't see the lecture at all. Hmm. They say, why to see lecture when as is it is not going to come in the exam. So they don't see the lecture. Then they don't open the book. Hmm. And directly they attempt muzakkarat or other sources and try to memorize the solution of the questions. So please keep in mind, in this course, rarely we repeat the question. Rarely we repeat the question. Every time we try to make a new question, new shape. So if you have concept, you can solve it. But if you do not have the concept, you cannot do it. So it is a concept oriented course, and concept develops slowly, slowly, slowly. Like a tree grows slowly, slowly, slowly. Child grows slowly, slowly, slowly. So concept grows slowly, slowly, slowly. So on every day, every lecture day, if you are studying the slides, then you are reading the book. Okay, this will make your this will develop concept in you, and then when you will practice problems, it will make you perfect. Okay, okay, Mr. Muhammad, please.
Yes, doctor. In the exam, is there write the definition of anything? For example, write.
Uh, Generally, definition, etc., we do not ask. We generally ask the numerical problems, but sometimes we also give multiple choice questions. So in those multiple choice questions, you may find some question related to theoretical background, eh, theoretical understanding, not the definition, etc., but by theoretical understanding.
Yes, so I should only just read it to know, but not memorize it. Yeah, I mean not write it in
Yeah,
the.
means no need of memorizing the you will not find much theory here. Actually, it is all concept oriented course. So 90% it is all concept oriented. Definition etc. are very few. Mm. So if you and develop the concept, inshallah, you will be perfect. Okay, and that's why I'm saying regular effort is very important. Regular reading, even if you give 10 minutes, it is more worthy than giving 2 hours after 3 days. Yeah. Because on the very same day when you go at home, whatever I have taught, if you give 10 minutes, that will absorb in your mind. Yeah. And if when you revise it later, you will be able to remember everything which I have discussed. But if you did not revise it on the very same day, next day if you are doing it, maybe 20-30% you will not able to recall. And if you do it after 1 week, maybe 80% you cannot recall. And if you do at the time of exam, so it will be as you did not take this course at all. Eh? So, so we have the lectures on only 2 days, the Sunday and Thursday. So at least on Sunday and Thursday evening, you take a cup of gahwa chai and just glance through, go through the lecture slides. It won't take more than 10-15 minutes, but it will develop concept, and what I am teaching, it you will be able to absorb in your mind. eh? And then later when you will practice, you will not feel any difficulty. So this should be the strategy, not the opposite, which I told just that don't see the lecture at all, don't go through book at all, directly attempting problems without having the proper concept. It will not work. And when we set the exam, keep in mind our reference is our lecture, eh, because we want to assess you what we have taught, eh, whether you have understood it, you have learned it or not. So do not ignore the lectures. Again and again, I will say. Yes, Mr. Omar.
Doctor, for the what do we have? Is it a tutor or practical or what? The other lecture.
Uh, in the tutorial, no,
Yeah.
tutorial means practice session. Tutorial means practice. So that is the a tutorial teacher will be assigned to you so that he will enable you to practice more and more problems. So either he
So
will
it's
say,
problem solving.
yes, it is a practice session. Tutorial means
It's
practice
not
session.
lab.
No, 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 not lab. This
Okay.
demonstration is the at the end of the semester. We have developed a small lab where we have models, eh, which we will show you so that you get a real feeling of the of statics problems. So that is a model demonstration lab. Only once or twice you will go over there. That's all. Hmm.
So we will visit the lab at the end of the
At,
semester.
at, at the end of the semester, near the end of the
Okay,
semester, yes. Mm.
thank you.
But tutorial is for practice. Tutorial means practice session for your practice. The engineer will be there who will either give so many problems so that you practice more and more. Okay, that is the purpose. Mm. And since last semester, the midterm exam dates are coming from the college. Mm. Before we were used to decide ourselves, but from last semester, the midterm exam dates are coming from the college. So inshallah, college will announce very soon the dates of exams. Generally, the first midterm is in the 6th week of the semester, and the second midterm will be in the 12th week of the semester. Okay, now I come to the topic. You see, in statics, many times you will be using the or you will be hearing the term particle. eh. So, what we mean by the particle? Particle essentially means zarra, elementary mass. Okay, but here in statics we don't mean that particle as a elementary mass like atom or etc. No, particle means here a body of such a size, such a small size, that its mass is uniformly distributed within the body. It means at any point you go, you will find the distribution of mass is same, or you can say the density is same. Okay, so that is small size of the body in which mass is uniformly distributed everywhere, or its density is same everywhere. And second thing, if this particle is in motion, then all the all portion of this particle, eh, they will have the same velocity and same acceleration. For example, if like for example, if you say your football, it's a particle. So if you hit the football, it is moving with certain velocity. That means each and every portion of the football is moving with the same velocity. And if it is having the acceleration, because before it was zero velocity, now it's having some other velocities. So acceleration is also same for all the portions of the body. Then this body can be treated as or can be called as particle in statics. So when we say particle, that means a small body having the same mass distribution everywhere, and if it is in motion, then its velocity and its acceleration everywhere is the same. Now I am come to the Newton's laws. So as you know, there are three Newton's laws, which are the basics or the basis of the mechanics. In fact, okay. So these Newton's laws basically are nature's laws, and they are the laws which is given by its creator, eh, or the Allah subhanahu wa ta'ala, that this that every natural object, or every object that has to follow these laws. And when you will read these laws, you will realize that everybody knows this law. Okay. So what is the contribution of Newton? Newton's contribution is that he observed it and then he has given words to it. But when you will go deep into it, then you will realize that everybody everyone knows about it. It's like, it's like a poet or shair. When a poet or shair sees something, eh, he is able to give words to it, and a common person may not be able to give words to it. For example, if you go to a very nice place where there are mountains, very nice river, very nice weather, very nice flowers, you will say, okay, mashallah, everything very nice, very beautiful. But when a shair looks at it, when a poet looks at it, he starts poetry, and then he explains what a common person is not able to explain. So same thing here is also from the Newton, that he observed and then he has given words to it. But they are the nature's laws, and unconsciously even every human being knows about it. And if I read these laws in a very local language, common language, you will feel that really there is nothing new in it. So how many are the Newton's laws? Anybody knows?
Three.
Three.
There are three laws of Newton. Very good. So any idea about the first law? What is the first law of Newton?
Yeah, that it's written. Should I just read or what?
It's written, but can you speak in your language? What is the first law of Newton?
The first law says that if there is no, I will try to say it from my own words, by my own words. If there
Okay,
is
fine.
object tends to
Okay,
stay in
okay,
its I don't know, motion or if there is no external forces acting on the object, if it's moving, it will keep
keep
moving.
moving.
If it's at
Okay,
rest, it will stay at rest.
yes, very correct.
Yeah.
Yeah, this is the first law. Yeah. So if I say in a very simple language, it means as the shay is, as the thing is, it will remain as is unless there is a force to change it. What I mean to say, suppose this is a pen, I keep it on a table, say at an angle of 40 degree. So this pen will remain there as is until the day of Qiyamah, unless there is someone or unless there is a force that changes it. So even if you keep it at 40 degree and after 10 years you find it has become at 41 degree, that indicates that some forcing agency came, or somebody has come, or some wind or anything has come which has changed its position from 40 degree to 41 degree. So according to Newton's, as the shay is, it will remain as is forever. Forever means if it is moving, it will keep moving in a straight line in the same direction forever with the same velocity. Or if it is not moving, it will at rest forever as is. No change can take place unless there is a force to change it. So this is the Newton's first law. This is also called law of inertia. Law of inertia. What is law of inertia? Law of inertia means uh, this you can say law of resistance to change. Means let me explain the inertia. Word inertia. Inertia means resistance to change. Means every shay it resists any change to it. And to overcome this resistance, you have to apply force. Okay. Even in our day-to-day life, you see, suppose you are sitting on a chair. I say, move from this chair to other chair. Maybe in respect of your teacher, then you may move, but it will come in your mind, or why unnecessary you are disturbing me? Hmm. Why unnecessary you are disturbing me? So you will not like to move. Okay. But the respect of the teacher, this is one type of force. Because of that, you may move. Okay. In the family, the small children, and the morning they don't want to go to school, and they try to resist not going to school. Then what you do to enable them to go? There are two things. Either you give them bashara. You say, oh, mashallah, if you go today, I will take you in the evening for pizza. Or you will offer him to some chocolate. Or you will give him some real that when you go to school, you buy something. So by these ways, by these forces, you try to change him his intention. Or sometimes you give him the threat that if you don't go, I will hit you by this scale, eh, or by hand. So everything, this resist change, and to overcome this resistance, you have to apply force. Okay. So say, like and this inertia, this resistance to change, it's proportional to. It depends on the mass of the body. More is the mass, more is the inertia, more is the resistance. For example, if a truck is standing and I ask you, go and move it by your own hand, you will say it is not possible. Why? Because its inertia is very high. Its mass is high, so its inertia is high. Its resistance to change is high. So you need a very large force to shift it from one point to another point. But if you have like a mouse of your computer, if you want to change its position, very easily you can do, because its mass is very small. So its inertia is small. So its resistance to change is small. So easily you can move it from one place to other place. So every shay has inertia. Okay. And because of that, to bring any change, we need to apply force. Even if you see, if you bring all the materials and then you start saying, uh, become house, become house, become house, become house, it will not become house, unless you apply force and you make the you do construction, and then only it will become house. So in our deen, when we say na amre kun, Allah subhanahu wa ta'ala has amre kun. What is amre kun? Amre kun is simply that no shay has inertia before the commands of Allah subhanahu wa ta'ala. So as he says, it becomes as is. and to our command it does not, because to our command every shay has inertia, resistance to change. When we will say it will not change, but to our commands of Allah subhanahu wa ta'ala, every no shay has inertia, every shay seizes its inertia. So as he says, things become that way. So this is the first law of Newton, that as the shay is, it will remain as is forever. It means if it is at rest, it will remain at rest forever. If it is at motion, it will remain in motion with the same velocity in the same direction forever, unless there is a force to change it. And this force also must be an unbalanced force. If you have a balanced force, means two forces apply of equal magnitude in opposite direction, then also it won't make any change because the net force will be zero. So balanced forces means the net force is zero. That will also not bring any make any difference. So technical definition of the first law is a particle remains at rest or continues to move in a straight line with a uniform velocity, with the same velocity, if there is no unbalanced force acting on it. So if no unbalanced force is acting on a body, as the body is, it will remain as is. If it is at rest, it will remain at rest, and if it is in motion, it will remain in motion. So you must realize that this, you know what is new in it. I mean, a common person knows that if you leave it, it will remain as is unless there is somebody or something comes and change it. So even the people were knowing about it from the very beginning, but Newton has given technical words to it. Okay, the second and third law, inshallah, we will discuss in the afternoon class, because I have to take attendance now.